be quite different from the previous one. Right. A bit lighter, hopefully. Like this talk is a mixture of both easy and hard, if you like. The easy bit is just look at the pictures and that'd be cool. The hard bit is, if you want to actually do this sort of stuff, there's a little bit of a learning curve, but it's all possible. So I'd like to sort of give you some inspiration on, you too can do this. Where this is what I'm about to explain to you. What I'm wanting to do here mostly is give you a bit of an introduction to geographic information systems, and particularly sort of web-based mapping and things like this, and to put a bit of a twist on it rather than just doing something over the top of Google Maps, which there's about 300,000 of these sort of tutorials on the web. I'm going to do it over sort of some kind of imaginary map, a different base layer underneath, just because, well, what the hell I can, and there's stuff available. Now, the good news here is that everything I'm talking about here is there's all working code on GitHub. There's URL on the last slide. So, just play along, nod your head wisely, and pretend you understand what's going on. And then you can download the code later on, and there's a quite a long readme with all the sort of, here's all the this you need to do set up, and here's how to do the pictures and so on. Alright, so here's what we're trying to get to. As far as I know, this island does not exist anywhere. I drew it a few years ago. I'm not really good at drawing, but it is what it is. There are plenty of tutorials around for how to create things like this. And the goal here is to walk through how do we create something like this. Like this is basically a screenshot of a web page. There's a map there, there's some paths, they're kind of visible on the screen, maybe not. There's some little yellow pathways around there, there's a few dots indicating, in this case, significant landmarks or something. I mean, I think I once had some kind of crazy backstory here of a guy shipwrecked on an island, and this is where he wandered around, and one of the dots off the coast was where his ship got wrecked, or where he saw a mermaid, or who knows what, right? It was not particularly well fleshed out a little bit, but there's potential. The problem with this is it's not trivial, but it's also not impossible. So, again, this is why I'm here. There is, to set expectations here, there is a little bit of setting up required to make mapping work on your laptop, but everything I'm talking about here runs on my laptop with, I can get it set up in Scratch in about 10 minutes, because I know what I'm doing, but there's a little bit of persistence required here. The other thing is, it's something new, and we're all afraid of new things, so that shouldn't be a problem, but sometimes, there's just a bit of a hurdle to get over there. So again, look, pretty picture. You want to do this, right? It's worth persisting. To solve these problems, we have, everything I'm talking about here is actual running code. Nothing has been faked. Well, everything's been faked in the code, but I mean, nothing has been, it's imaginary maps. It's all fake, but all the code works. It's all on GitHub. You can actually download it if you want. Or if you can't wait to the end of the slide, if you can't find it on GitHub by searching for my name, well, all right, maybe the learning curve's a bit too hard, but it's possible. To understand all this, the sort of things you would need to be able to do something like mapping. And here I'm cheating, well, not cheating again. I'm using tools that already exist. I'm not reinventing wheels. Django exists as a sort of web framework or Python library or whatever you want to call it for creating websites. In addition to Django, one of the very early successes for Django as this thing could actually work as an extensible framework of code is a guy called Justin Braun from the US wrote a whole bunch of GIS extensions to Django, which is basically mapping extensions to Django. GIS stands for Geographical Information Systems, and it is the area of work of doing data processing with geography, because whereas normally with data processing we're talking about strings and numbers and dates and maybe booleans, with geographic information now you have points and lines and polygons and altitudes, latitudes and longitudes. And you've got all sorts of complicated problems, like it turns out we don't actually live on a flat Earth. There is a sphere involved, and most of our sort of representation on the screens are two-dimensional, so you've got conversion between different points. All sorts of complicated stuff like that. So there's this whole area of GIS that deals with it. And this is not a new area, this is not even a some kind of new trendy thing. It's been around for decades because mining mining companies and natural gas exploring and petroleum companies, they find these, they find a repository of natural gas in the ocean somewhere off the, out in the ocean. They need to know how to get back there later on when they have the money to dig up these things. Like Discovery tends to work with natural resources. You find the thing and then you go off and get lots of money so you can dig it up from your company or whatever. And so, but companies like BHP and sort of related companies like this have already got lots of mapping technology and they know how to put points on a map and convert between them for different regions and stuff like that. So when computers come along now, we can all have them in our laptops or in our living rooms. Adding something like GIS support to computers is basically a matter of codifying what already exists, which is good. So where I'm going here is there's already a lot of standardization around this. It isn't a rapidly moving area, which is really, really nice. Because it's complicated enough already. So GeoDjango is this extension to Django. It actually comes out of the box with Django to add the GIS support, to add the mapping support. It's not the only thing that adds mapping support, because you need a database that knows how to do polygons and lines and so on, but all the major databases have those extensions. And you need some JavaScript, and we'll get into that later on. But it provides a good starting point. The other good thing is when Justin, particularly, I'm going to mention Justin's name a bit for a little while here, because he pretty much single-handedly drove this portion of Django back in 2007, 2008. He wrote lots of documentation, because this is weird stuff. When I started doing this, it was like, I understand the words, but I don't understand when you put them into sentences what I mean. Google Maps works, but it seems a bit magic. And so there's a really good tutorial that goes through how to set it up on Linux and Mac and Windows, and then download this file of all the country boundaries in the world, and then it just walks you through it. Suddenly you have a map of all the country boundaries in the world displaying in your web browser, running locally. So for our purposes here, if you're up to the point of you can download Django and you can install this, and you can follow the GeoDjango tutorial, and that is probably, I don't know what, an hour and a half or 2 hours of your life, maybe a Sunday afternoon, something like that. At that point, you've crossed over the hurdle, you're at or crossed over the hump of the hill. It's all downhill sledding from there. Next step is something like read the code I've written here, or read something. Part of why I'm writing this is there's not a lot of examples around of not the GeoDjango tutorial. So this is maybe another example there. And then finally, for heaven's sake, do something better than my Mac, right? It's fairly rubbish. Somebody's got to be able to do a proper dungeon or something like this. So, GeoDjango, and this is just, again, a static screenshot. Most people know, even if you haven't used Django, we've seen a couple of examples today, one of the benefits it brings as a library, as a system for creating websites, is a very nice administration interface out of the box. And this is partly because it was written for an environment where, at the same time as they were creating their database tables and they needed to be able to populate them. It was a newsroom where the reporter was sitting right there with the data ready to enter it, while the coder was sitting there creating the models to store the data. And I'm not making this up, they sat literally that far apart in the early days of Django creation. No pressure there when you're trying to do your work. So GeoDjango, again, did the right thing. Out of the box, it adds something to the administration space. The top third of that screenshot, the text with boxes, it doesn't matter what's in them, just understand it. There's sort of labels saying, look, here's some names and some numbers. That's standard Django administration interface. The map down the bottom looks pretty funky, but that's what GeoDjango brings to the party, along with some JavaScript and things we'll get into in a minute. This happens to be a map of the lower southwest corner of Tasmania in Australia. I probably should have localized it and done part of the Philippines or something. The highlighted region here is, so the back layer here is part of Tasmania, down south in Australia, and the highlighted region is a water catchment area. All the rain that falls on that section flows to the one location. How does this work is sort of the next question. That's where I want to go. So the thing that sort of thought to keep in your back pocket on this is pretty much every mapping site you see is a mashup. By which I mean it's a combination of different data sources all layered over the top of each other to produce something sensible. Mashups are not maybe as trendy now because everyone just thinks of them as natural. But they were, for a while, sort of the big thing on the web of pulling data from different sources in the browser, maybe without permission of the sources, just do it. Combining that multiple data sources is sort of an obvious example that maybe you don't see much, but you occasionally see maps of tweets from around the world being placed on a map. So every tweet has a little A lot of them have a geolocation attached to them. Okay, we can take Google Maps and their API, we can pull in the right location, we can put all the tweets on there. I get there's some intelligence involved here because you don't want to plot all 6 billion tweets that happened in the last minute if you're only doing a map of vanilla. You only want to put the local ones. But hey, that's computer science, software engineering. That's the bit we need to be able to do. So just remember this, that everything we're talking about when you're trying to work out how do I do X, Y, Z with mapping is where do I get the different bits of data from and how do I combine them. So here's the type of stack of things we're talking about, and I'm going to walk through this from top to bottom over the next few slides. But in this case, I'll just start from the bottom and work out. PostGIS is a database. It's actually PostgreSQL with GIS extensions. It happens to be the one I'm using here. There is also GIS extensions for SQLite. There are GIS extensions for MySQL. They're not as awesome as the ones for SQLite and Postgres, but they work. There are similar GIS extensions for Firebird and Oracle and Microsoft SQL Server and things like that. Pretty much every major database has GIS extensions. Whether they're freely available or not is a different question, but certainly SQLite, MySQL, and Postgres all have their extensions as you can download them out of the box. The same way you got Postgres is where you go get the GIS extensions. So think of that PostGIS, bottom right hand corner there is, this is the database. It's a standard SQL database. It knows how to, it can also store polygons in there and lines and points. Points are easy, they're a pair of numbers, but a line is interesting. How would you store that? Or a polygon, you're basically storing the corners, a sequence of vertices. Django.contrib.gis is the complicated technical name for GeoDjango. You can see why we call it GeoDjango. That's the import part for it. So it's providing some of our data. Mapnik down here in the left is a separate server that knows how to serve basically big pictures of maps. So in the original thing I showed you, the island map, that's being served up by Mapnik. So I'm actually, in part of this talk here, I'm going to be talking about 2 different web servers running at once. But like I said, everything's a mashup. I'm pulling down from different sources. In this case, both the sources might run on my laptop, but they're 2 different web servers. In real life, of course, they run on different servers or maybe the same server, but they could be different pieces of code. The cache is hopefully self-explanatory. I might get to why you need that, but it's not stupid to think about how am I going to cache some of this data. And then finally, the openlayers.js sounds like a JavaScript file. It runs in the web browser to combine. It's the thing that does the mashing. It's the thing that pulls all the data sources together and creates the pretty picture. So back here in our admin interface, you can see there's a bit of sort of chrome here in the top left and over on the right there with the plus sign, some navigation things here apparently going in and out. That's all open layers. So let's start from the top then and work down with a bit more detail. Open layers was, well, it's a JavaScript framework, like multiple feeds. It looks kind of nice. It's customizable up the wazoo. You can get something running with open layers in about 15 minutes. You can spend the next 5 years of your life making it look just right because you can customize everything. It's really nicely written code. It was originally sort of put together by the OpenStreetMap project, which is a big crowdsourcing initiative to have people wandering around with their GPS receivers, sort of plotting all the roads on the planet, basically, walking tracks, dog tracks, who knows what, and putting them all into a big database, a la Wikipedia-like style thing, but for street maps, they needed a nice way to present their results. They came up with open layers, and they open sourced it, everyone uses it, and it's fantastic. So it doesn't have to look, the pictures I'm showing you here are the standard open layers look, but it doesn't have to look like that. It just gets, you can do whatever you like there, which is nice. Mapnik is a server. The main code for Mapnik is written in C++, but it is the same people who developed the C++ code also have written a whole bunch of Python API extensions for it. So out of the box, it comes with a whole bunch of Python support. So you download Mapnik, you download Mapnik Python, you open your Python prompt, you import Mapnik or import Mapnik 2, and away you go. For a long time, and look, again, Mapnik has a lot of support from the OpenStreetMap guys, so it's, this is industrial strength code that runs serious websites for serious people. A bit of persistence goes a long way here. The big deal with Mapnik is it understands tiles. So think of a world map, and I'll pretend we're on the flat Earth here. We've got a big rectangular world map. That's a nice picture of the whole world. If I'm only showing Manila, I don't need to show the whole world, and I don't need to download the whole world map. And in fact, it's probably not big enough to show me enough detail. I know Manila seems very large, but on the scale of the world map, it's actually just a little dot. So Mapnik understands that, and you can have different resolutions of tiles. You see this on Google Maps. If you zoom in, you see the square start to fill in on the screen, because Google Maps is a whole bunch of different versions of the Earth in different squares and tiles. And they serve you up the right squares to fit your screen at the right level of detail. Mapnik is the type of technology that handles that. You could say, okay, I've only got my island at one resolution, but I can do much closer resolution versions as well, so separate images for more blown up versions of the thing. Mapnik will serve up the right magnification. It can take input in both raster and vector formats. Vector formats are lines. It says it starts here, it finishes here, so it's infinite sort of precision. It scales up. Raster formats is what you think of as just pixels on the screen, row by row, one raster line at a time. Raster formats tend to be good for base layers of maps, things like satellite images or stupid made-up islands like I did, that where you've got a picture, the best you can do is zoom in. Vector formats are great for streets and flight paths and railway lines where you've got specific waypoints and straight lines between them. Mapnik isn't the only thing that can do that, but it's sometimes useful for combining different bits of information. Tile cache, I'll just talk about quickly, is the name of one of many programs that know how to cache things. And again, it understands tiles. That's the secret here. It's not like web pages, which are HTML and CSS. It needs to understand geometry, at least of the XY form. It needs to understand, you are looking at this box on the screen, what tiles do I need to serve up so that it covers this box. It doesn't matter if I serve you a bit of information that isn't displayed in your box, but I should leave gaps. So tile cache, the other reason I mentioned tile cache there is it's one that's written in Python. I'm not sure if it's used highly in production code, but it certainly seems to be reasonably well behaving. ModTile is an Apache version. There's one called Tile Stash. I think the guy was riffing on Mustache there. I'm not completely sure about that one. But they all work. ModTile is the one that the OpenStreetMap project used. And it's just used as a normal cache that understands tiles. The sort of strategy that people use for caching, by the way, is, I'm not sure of the exact numbers these days, but a few years ago, OpenStreetMap would basically, every 3 days, they would recompute every tile image for their data. So what they would do is they'd run through all of their available data, compute all of the tiles and all of the resolutions, and put that into the tile cache that preceded. Because hardware was cheap, computation power, CPU power was a little bit more expensive. It took a while. With the equipment they had, storage was cheap, CPU power was more expensive by that. It took them 3 days to run through their whole set. So they'd run through the set, they'd finish, they'd start again, just keep going. So if you put new data into OpenStreetMap, maximum would take 3 days to show up. Every time you send data to Google Earth, or pull data in from the internet on Google Earth, it comes in this format called KML, which is kind of like an RSS feed or an AV feed, but again, has certain geometry aspects about it. It understands points and lines and latitude, longitude, and projections. And so GeoJango comes with some very nice views, very nice shortcuts for saying, I give you a bunch of data, please send that out in KML format so that someone can take my GeoJango output and put it on Google Earth. Nicely enough, that's also a format that's understood by open layers, and so, hey, we can cheat. I'm being on cheating, as you probably understand by now. We can output KML, that appears on open layers, easy win. So that's all the pieces. Like it's a little bit arbitrary. I've sort of picked two different ways to get my data here. In my particular case that I'm talking about with this island and various tracks on it, if we just go back to the beginning again really quickly, because I really should insert a version of this slide. Mapnik is providing the island in the background here. The thing called, if you can see, base layer, in the little blue box in the top right corner, the first section says base layers, and then the second little section says overlays, and overlays has tracks and notable points. So Mapnik is providing the blue, the green, and the mountains and the island, basically. GeoJango is providing the yellow paths and the dots, because it is saying what happens is open layers, which is pulling everything together here, is saying I need to get information about a box that is this big, and it's specified that in latitude and longitude terms. And it sends it to Mapnik, and Mapnik says, oh, okay, so the base, and OpenLayers knows that for the base layer, go here, which is to Mapnik, and for other information, go over here to GeoDjango. Again, they're just URLs to OpenLayers, and I'm just saying it's a mashup, pull data from this URL and this URL and put it together. And so Mapnik sends back the nice island map, and GeoDjango sends back the paths and the dots. And if you zoom in on this map, it's sending a slightly smaller box to the back end, and so GeoDjango maybe doesn't have to send back every dot because not all of them are in the screen. And we'll see some code in a minute. And really fast because you see these bits. Diagram. Right. So to do out of the box with the admin interface, we saw before I had a map of part of Tasmania and Australia sitting up there. That's because by default, OpenLayers knows about our world. Pretty safe default assumption for mapping stuff, you're probably mapping the Earth. But you can map other things. And I got the sort of, the genesis for this talk many years ago was actually saw somebody at Google who took some NASA had released data, satellite shots of Mars. And they basically packed up Google Maps to do some Mars shots. Subsequently, NASA did Google Moon. And so you can go, there's a Google Maps of the moon. You can zoom in and see the Apollo landing site. If you zoom too far in, it starts to look like cheese. People have done mashups of like the GTA games and actually put them onto Google Earth and Google Maps and stuff like this. So it's the same idea. In this case, I was thinking, I was watching a video of this Mars one and thinking, that's pretty cool. I wonder how you do that. And this came out of it. So to make an imaginary map, like in this case, I've drawn an island. How do I set that up? I need to replace the base image. I need to tell GeoDjango's admin interface, go look over here for my base image. Don't pull the stuff off the internet for the normal thing. Mapnik is, to make this work, here I'm getting a little bit more into the code of what I'm talking about. So if, up to here you thought, all right, this is interesting, and you don't really care about the details yet, just, run along wisely and don't look like you're asleep. For those who want to see a few details, we're going to do sort of 5 minutes of, how the magic happens under the covers. WMS here is an abbreviation of an abbreviation. It stands for WSGI Mapping Server. So it's basically much like Django's own little run server, little standalone development server. The WMS server for Mapnik is a little standalone server that serves up mapping. It's great for development because you can just have it there running in the background, change the config file and restart it, everybody's happy. You don't use this necessarily in production, but the advantage of Python, it just works locally out of the box. Some actual code. Here is what a model looks like in GeoDjango. Now, if you've never seen Django before, just believe that classes are essentially mirroring what we store in the database. If you've seen Django and you haven't seen GeoDjango, you know what a model is. A GeoDjango model is essentially Django model with a little bit extra added. In this case, the very first field here, so the track, the name of this class is I'm thinking of a track as a path around the island. My poor shipwrecked soul went wandering around the island and somehow in the 17th century had his GPS system and recorded accurately where he was. You don't want to dive too deep into the details there. But okay, the first line is just the name of the track, whatever it might have to be. So that's a normal character field in the database, nothing special. Doesn't need GIS. The second one, the path, line string field. You might seem like we could have made that a little bit better, but again, this is reasonably standardized stuff. So the GeoDjango names mirror what the standards are for this GIS stuff. And a line string field is a particular way of storing a line. It's saying here's a sequence of points. It's not just a single point-to-point line, it's a sequence of points. Geography equals true there is you can kind of ignore that. It's a Postgres specialty to say when you're computing distances, take into account that these points might have different altitudes. That if you think about a triangle, if you've got a path along a flat bit, it's shorter than if that path also goes up the side of a mountain for the same latitude and longitude.